Hello and welcome to Titocan Solutions. Today, we are going to learn another form of logistic regression model. But have you ever wondered how it's possible to predict levels of satisfaction, like job satisfaction, based on factors like age, education, or income? I guess not. However, it's not everything that is just yes or no in statistics. Sometimes, responses fall under other categories such as low, medium, or high. This is where the Ordinal Logistic Regression steps in. So in this video, I'll be showing you how to learn Ordinal Logistic Regression the easy way using SPSS. Please stay with me on this channel to the end of this video as there are a lot of it to learn. My name is Titocan and this is Titocan Solutions, a YouTube channel for improving the knowledge of how to do things. First, what is Ordinal Logistic Regression? Ordinal logistic regression is a statistical modeling technique that is used to predict an ordinal dependent variable given one or more independent variables. But in a simple term, ordinal logistic regression helps you to predict how likely someone is to be in a higher or lower level of an ordered outcome based on factors you measure. For example, if you are a researcher studying job satisfaction among employees, you surveyed 20 people and collected details like their age in years, their education level such as primary, secondary, or tertiary, their monthly income, and how satisfied the employees are with their job. Do they have low job satisfaction, medium job satisfaction, or high job satisfaction? Then the research question that asks, does age, education level, and monthly income significantly predict a person's level of job satisfaction can actually be answered using ordinal logistic regression, because in ordinal logistic regression, the dependent variables must be an ordinal variable and the categories must have a natural order such as low, medium, and high like the researcher has collected. And the independent variables can be a mix of continuous scale variables and categorical nominal variables like he also has in his data collection. Now, if you still don't understand the concept yet, don't worry. You will understand it better during the hands-on demonstration with the data in SPSS. However, there are some assumptions that your data must satisfy for it to be tenable for the analysis. The assumptions are: 1. Your dependent variable should be measured at the ordinal level. 2. There should be one or more independent variables that are continuous, ordinal, or categorical. 3. There should be proportional odds. That is, the relationship between each pair of outcomes should be the same. 4. There should be no multicollinearity in your dataset. That is, predictors shouldn't be highly correlated. 5. Your data must have independence of observations. And 6. There should be linearity of continuous variables with the logic transformation, especially when there are numeric predictors or independent variables. Now, let's use this synthetic dataset collected by the researcher who studied job satisfactions among employees. This data has already been loaded into SPSS. If you don't know how to load data into SPSS and define the variable properties, please visit Titocan Solutions YouTube channel to see or watch my videos on Introduction to SPSS Software for Beginners, Part 1 and Part 2. As you can see from this data view window, we have 20 cases of respondents whose age, education level, monthly income, and job satisfaction have been documented. In this set of data, job satisfaction is the dependent ordinal variable consisting of ordered categories, while age, education level, and monthly income are the independent variables consisting of scale and nominal measures. For ordinal logistic regression, you have to ensure that the scale of measure for each variable is appropriately assigned. Now, to see this, go to the variable view window and ensure that the variables are well identified with the right scale of measure. Age should be a scale measure, education should be a nominal measure, monthly income should be a scale measure, and job satisfaction should be an ordinal measure. If your own is not like this, please change the ordering now. Now, let's recall the research question. Does age, education level, and monthly income significantly predict a person's level of job satisfaction? Then, let's state the hypothesis that we have to be used to answer this research question. The null hypothesis states that age, education level, and monthly income do not have any significant effect on the person's level of job satisfaction, while the alternative hypothesis states that at least one of the factors, such as age, education level, or monthly income, does have a significant effect on a person's level of job satisfaction. Now, let's perform the ordinal logistic regression in SPSS. Go to the menu bar and click on Analyze. From the sub-menu, put your cursor on Regression. And from the drop-down options, click on Ordinal to open the Ordinal Regression dialog box. In this dialog box, you have your variables in the box at the left. Now, since we have identified the dependent and independent variables, click on Job Satisfaction to select it, and then click on this transfer arrow key to move it to the dependent box. Now, we have the factors and the covariate boxes to fill. The question now is, which independent variable should go into the factors box and which one should go into the covariate box? This is a big question to answer, and the choice of variable is very important to regression models in SPSS because you need to tell the SPSS software which kind of independent variables you are working with. So let me guide you. Use your variables as factors if the scale of measure of the variable is nominal or categorical, and use your variables as covariates if the scale of measure of the variables is scale or continuous. So by virtue of this definition, now click on education level to select it, and since it is nominal categorical variable, click on this transfer arrow key to move it to the factors box. Finally, select age and monthly income, and since they are scale continuous variable, click on this transfer arrow key to move them to the covariate box. Now, let's proceed to the buttons on the right-hand side. There are 5 buttons here, but for ordinal logistic regression, there is nothing that is required of you to do in Options button, Locations button, Scale button, and Bootstrap button. The only button you should be concerned with is the Output button. Please, click the Output button now to open the dialog box. As you can see here, 3 boxes in the display section have been checked by default because they are important and relevant to the model's output. Now let's add just one more output. Go ahead and check the box for test of parallel lines. This selection will be used to test the assumption of proportional odds, which is a key assumption in ordinal logistic regression. Then click Continue to close this dialog box. Like this, we have successfully configured the SPSS system to process the model for ordinal logistic regression. Now go ahead and click OK to produce the model results in the output window. As you can see, the results have been produced. Now I will proceed to interpret and discuss the results to make strong data-driven conclusions. The first table you must consider before proceeding to interpret or discuss any other table is the test of parallel lines table. Now, let's scroll down to the table. This table provides the required information that tests the assumption of proportional odds, which is a core assumption in ordinal logistic regression and is also called the parallel lines assumption. Specifically, it checks whether the relationship between each predictor and the outcome is consistent across all categories of the ordinal dependent variables. For example, it tests whether the effect of age, education level, or income on the odds of moving from low to medium satisfaction is the same as the odds of moving from medium to high satisfaction. This same effect across threshold is the parallel lines assumption. Conditionally, you can proceed with interpreting the model as an ordinal logistic regression if the parallel lines assumption holds true, or the assumption of proportional odds is found tenable. This is only when the p-value is greater than 0.05. So in interpreting this table, you are strongly advised to focus only on the p-value of the general model. If the p-value is greater than 0.05, then the parallel lines assumption holds. But if p-value is less than 0.05, then the parallel lines assumption is violated. As you can see from this table, the p-value for the general model is 0.105, which is greater than 0.05. This means the parallel lines assumption holds true. The relationship between the predictors and the log odds of job satisfaction is consistent across the satisfaction level. What this means is that the main required assumption is not violated, and we can proceed with interpreting the model as an ordinal logistic regression. And again, we do not need to switch to a more complex model like multinomial logistic regression, whose video I have already published in my YouTube channel. Now that we are good to go, let's proceed to the case processing summary table above to see if all the cases of our sample data are used 100%. This table tells us how many data points or cases SPSS actually used in the analysis and how many were excluded. It helps you verify that your dataset is clean. But as you can see from this table, the number of valid cases of data used for the analysis is 20, accounting for 100%, meaning there was no missing values as all the data points or cases were used to run the model. This is very good and should be what is expected. The next table of result is the model information table. This table is checking whether the final model, which has the predictors like age, education level, and monthly income, is statistically significantly better at predicting the outcome of job satisfaction compared to the intercept-only model with no predictors at all. In this table, the p-value designated as SIG is a very important key. If the p-value is less than 0.05, then the model with predictors fit the data significantly better than model with no predictors. But if the p-value is greater than 0.05, then the models with predictors do not fit the data significantly better than the model with no predictors. So as you can see in this table, the p-value designated as SIG is 0.374 and is greater than the significant threshold of 0.05. This means that based on our sample, the predictors like age, education level, and monthly income do not significantly improve our ability to predict job satisfaction. This is not unexpected because the data I used for this demonstration was synthetically generated for the purpose of using it to show you how to perform ordinal logistic regression in SPSS. However, this doesn't mean the data is bad. It only means that the data produced a weak model. In this case, you need to look up to the goodness of fit results in the next table to decide whether to proceed or to retire to review your data and rerun the model. Now, let's proceed to the goodness of fit table. The goodness of fit table helps you assess whether your ordinal logistic regression model fits the data very well. In SPSS, ordinal logistic regression uses Pearson's test and deviance test respectively to compare the expected frequencies from your model with the observed frequencies in your actual data. If the comparisons are close, then your model fits the data well. But in this table, the p-value of the chi-square of Pearson's and deviance is key. If the p-value designated as SIG is greater than 0.05, it means your model fits the data well. And in this case, the differences between observed and expected values are not statistically significant. But if the p-value is less than 0.05, it means your model does not fit the data well at all. And in this case, the differences between observed and expected values are statistically significant, or that the model's prediction deviates too much from the reality. As you can see from this table, the Pearson's test gives us a chi-square of 38.515 with a p-value of 0.273. The deviance test shows a chi-square of 35.643 with a p-value of 0.391. Both p-values are greater than the statistical threshold of 0.05, indicating a good model fit, which tells us that the model's predictions are reasonably close to the actual data. So our model fits the data very well. But remember, good fit doesn't always mean the model is useful. In our case, the model fits, but it wasn't statistically significant overall due to the outcome of the results of the model fitting information. Your real project data can do better. Now, let's proceed to the pseudo arrow square table. This result table provides estimate of how much variation in the job satisfaction is explained by the age, education level, and monthly income. The pseudo arrow square values helps us judge the strength of the model and gives us a sense of how useful our model is in explaining the outcome. But they are only indicators and not definitive measures. In this table, there are three statistics, namely cause and snare, Nagasaki, and McFadden. Among these three statistics, Nagasaki should be used as the main reporting statistic because it is an adjusted version of cause and snare scaled up to 1, and it is the most commonly used and easiest to interpret. As you can see from this table, the value of Nagasaki is 0.221, which is about 22.1% when multiplied by 100. So, the model explains 22.1% of the variation in the job satisfaction. As you can see, the variation explained by the predictors is moderate, but the strength is relatively weak. But suffice to say, the predictors, which are age, education level, and monthly income, have some impacts, but there is still a lot left unexplained. Again, your real project data can do better. The next table is the parameter estimates table. This table is the heart of interpretation in ordinal logistic regression because it tells you which predictors significantly influence the outcome, in what direction, and by how much. By implication, this table helps you to understand which variables matter, in which direction they influence the outcome, and how strong their influence is, which explains the odds. However, the most important key columns in this table are estimate and the p-value columns respectively. The estimate is the log odds coefficient and it shows the magnitude and direction of the effect, while the p-value is an indicator of whether the predictor has a statistically significant effect or not. If the estimate is positive, it means the predictor increases the odds of being in the higher category, but if it's negative, it means the predictor decreases the odds of being in the higher category. On the other hand, if the p-value is less than 0.05, it means the variable significantly affects the outcome, while if the p-value is greater than 0.05, it means the variable does not significantly affect the outcome. As you can see from this table, the thresholds for job satisfaction equals 1 has estimate of -2.033 and a p-value of 0.389, which is greater than 0.05, and job satisfaction equals 2 has estimate of 0.942 and a p-value of 0.684, which is also greater than 0.05. In most basic analysis, the estimates are not interpreted directly. These are cut points used internally by SPSS to separate the ordered response categories for job satisfaction such as low, medium, and high. However, the non-significant p-value suggests the separation between categories is not highly distinctive in this data. For location of the predictors, age has estimate of 0.002 and a p-value of 0.959. This means the age has a very small positive effect on the odds of higher job satisfaction, but the effect is not statistically significant as the p-value is greater than 0.05. Hence, we can say age does not significantly influence job satisfaction in this model. Monthly income has estimate of -8.847 exponential -6, which is essentially very close to 0, and a p-value of 0.285. This means as income increases, there is a tiny decrease in the odds of being in a higher job satisfaction category. But again, the effect is not statistically significant as the p-value is greater than 0.05. Generally, monthly income does not significantly influence job satisfaction in this model. Before I discuss the education level in this table, let me quickly refresh your memory. Recall that during the configuration process, we used education level as a factor categorical predictor. So as a result, SPSS has created dummy variables such as education level 1, education level 2, and education level 3. In this case, education level 3, which is tertiary education level, was used by SPSS as the reference category and therefore has estimate of 0 and a p-value of 0 and zeros across the entire columns. Education level 1, which is primary, and education level 2, which is secondary, are compared to the tertiary education level 3. I am sure you can recollect this. Now, let's proceed. For education level 1, which is primary education level, it has estimate of 1.952 and a p-value of 0.141. This estimate is a positive effect, meaning individuals with primary education level are more likely to report higher job satisfaction compared to tertiary education level, but the p-value of 0.141 is greater than 0.05 and therefore is not statistically significant, indicating there is no significant difference in satisfaction between secondary and tertiary education holders in this sample. For education level 2, which is secondary education level, it has estimate of 1.449 and a p-value of 0.220. This estimate is also a positive effect, meaning those with secondary education may have higher odds of satisfaction compared to tertiary education. Yet again, the p-value of 0.220 is greater than 0.05 and therefore is not statistically significant, indicating there is no significant difference in satisfaction between secondary and tertiary education holders in this sample. Generally, none of the predictor variables such as age, monthly income, or education level had a p-value below 0.05. This means that none of the predictor variables significantly predict whether someone reports low job satisfaction, medium job satisfaction, or high job satisfaction in this sample. Interestingly, the estimates for primary and secondary education were positive, suggesting that people with less education might feel more satisfied, but those results were not statistically significant. So, with this sample, no predictor had a strong or clear effect on job satisfaction. What else did I forget to mention? Please remind me in the comment section, because right now we have come to the end of our class today on the Ordinal Logistic Regression in SPSS, and I hope you'll be able to replicate the procedure to run the analysis on your own data and interpret the results. But wait, don't stop there. If you found this tutorial helpful, click the like button, share this video, and subscribe to Titocan Solutions for more data-driven insights. And then turn on the notification bell so you never miss out on our latest tutorials. Do you have questions? Drop them in the comment section. Let's keep the learning going. And hey, if you are working on a real-world project and need guidance, let's talk, because learning never stops. Thanks for watching, thanks for sharing this video, and thanks for subscribing to Titocan Solutions, a YouTube channel for improving the knowledge of how to do things. See you in the next video. Bye.